triangle equals. What do they add up to? 180. Excellent. What makes an isosceles triangle special?
It has
two equal sides, good. We can show that on a diagram by going dash, dash. And two equal angles. And we can show that on a diagram by going whoosh, whoosh. So, isosceles triangle has two equal sides and two equal angles. And there are lots of isosceles triangles that get drawn in circles. This is what you have to be looking for. They will say, here's the center. Shoo, shoo, shoo. That makes an isosceles triangle every single time. Why? Because you have two radiuses that are the same. And as soon as you have either the two equal angles or the two equal sides, okay, then you know it's isosceles. So two equal angles will also tell you two equal sides. Two equal sides will also tell you two equal angles. An equilateral triangle has three equal sides. Do. And all the angles are equal, so they will all measure 60 degrees. 60, 60, 60. Beautiful. If you have two sides in a right angle triangle, let's say this one is 3, this one is 4.
Oh, that's a great 4.
It was a great 4, just wait for it. Oh, it's going to double line it. Put it down. Okay. If you have two equal sides in a right triangle, you can find the other one, see? With the formula what? A squared plus B squared equals C squared. So you could do 3 squared plus 4 squared. Does anybody recognize this? This is a famous triangle. Does anybody recognize it? It's the 3, 4, 5 triangle. Yeah, I think that's probably what it's called, the 3, 4, 5 triangle. It is the smallest triangle where all the numbers are whole numbers, and it works. And there are more that works, yeah. The 5, 12, 13 triangle is famous, the 7, 24, 25, right? How many do you know? Do you know the 18, 15, 17 one? Oh, well, you do now. 8 squared plus 15 squared, 64 plus 225 is 289, which happens to be 17 squared. Okay. When two lines intersect, two pairs of congruent angles are formed. These would be, which ones are the same? This angle and this angle. So we could say angle AED and angle BEC. Maybe I'll put an equal sign in here because they would be equal. And then I'll switch colors, and this angle is going to be equal to this angle. So angle AEB would equal angle DEC. So the opposite angles when lines intersect are equal. Here's a word for you. Congruent. What does congruent mean? That is a good question. Right? Sometimes as a math teacher you see a word, and since you know what it means already, you go, oh, da 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 da. But that might be a new word for you. Congruent. Means equal. If things are congruent, they are equal. So sometimes I feel like if I was a math student, I'd be like, why do they, if they have the word equal already, why do they go and invent a new word? Right? Like my grade 12s, they thought, did you know that if two lines are 90 degrees, there's a word for that? Does anyone know the word for two lines being 90 degrees? Perpendicular. Have you ever heard of that word? And my grade 12s just learned that there's like, I guess math people felt that there wasn't enough words for perpendicular, so there's another one, orthogonal. It's like, orthogonal. Also means perpendicular. Also, and some people, why don't we just say they're 90 degrees? Right angle. There's another one. We have all these different words for the same thing just to make our lives more complicated. Oh, here we go. Well, look at that. Two lines are orthogonal if they cross at an angle of 90 degrees. And if this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90, there'd be 90 degrees on all of those. Because two angles, oh, we don't need that W there. That is a mistake. Two angles are supplementary. There's a new word. If their sum equals 180 degrees. And anytime you have two angles on a straight line, they will always add up to 180 degrees. What happens if you had a straight line and I told you this one was 60 and this one was 70? That is bad. Those don't look like 70 and 60. Let me actually draw them better to scale. This looks more like 30 and 40. How big is the angle in the middle? 110, because they have to add up to 180. One line bisects or is a bisector of another line if it cuts the line into okay, so what can I say? Two equal parts. These are lines that go into, I'm going to put two equal angles. So this is 90, this is 90. So if I had two angles like this, and I cut them in half perfectly, then this would be 30, and this would be 30. We can bisect an angle. We can also bisect a line. So if this whole line is 10 and I cut it in half, then this would be 5 and 5. So bisect means to cut in half. One line bisects is a bisector of another line if it cuts the line into two equal angles. If it was a line, if this said a line segment, because a line has arrowheads and goes on forever, a line segment ends and has a length. Question? The original angle would have been 60 degrees. And if we draw a bisector for that angle, it would cut it in half. So this one should pass through. Let's add the word segment here. Because here we're talking about a line segment. There's a typo in there. It should say line segment. If it's a bisector, then it passes through the center of that line segment. Canadian way. I think it's just American is ER and British and Canadian is supposed to be RE. You may.
No, I thought the same thing. Center is like that's what I thought.
Oh, like a super center.
Like even like a center, like a hockey.
Well, what's a hockey arena in the States? So you think this RE should be like a hockey arena? So air Air Canada Centre is in where? Toronto? So then it would be RE, but what a Staples Center, isn't that in LA? Check if that one's ER. ER. So, and is it spelled right on there? Yeah. So I think it is just an American and a Canadian, different ways of spelling it. Same thing with centimeter and meter. Canadian way is RE. So I just use an M. Keep it simple. Abbreviate when you don't know how to spell something. Okay. So, 2 days ago, you had all of those definition sheets. Was anybody not here 2 days ago when we got the starting things for circles? So you had, there's a video on this, and then the investigation, you had to create your own definitions. So here are some important definitions for a circle. Okay? What is a circle? It is an infinite amount of points, all the same distance, which is the radius, from a center point. How did I do? I don't think my center point looks, it looks there, maybe? Okay. So draw a center point. That makes a circle. Okay? The circumference is the perimeter or the length of a circle. It's on your formula sheet, and we can add this in, that your circumference is 2 pi r. Okay? Diameter, I'm going to underline in green, and I'm going to draw one on the diagram. A diameter is any line segment passing through the center of the circle with endpoints on the circle. So I just read that definition and realized that it wasn't quite right. Because I could draw a line segment that goes through the center but stops before it hits the edge of the circle. So diameter goes through the center of the circle, but its endpoints are on the circle. That makes a diameter. I'm going to underline radius in purple. A radius is a line segment joining the center of a circle to the circumference. So any point that goes from the center out to the edge, that's a radius. Any point that goes through the center all the way across, that's a diameter. Next color, I'm going to go to blue. I'm going to underline chord in blue. This was one of the definitions you did the other day. A chord is a line segment with both endpoints on the edge of a circle, or on the circumference of the circle. So a diameter is a special kind of chord. And in fact, the longest possible chord is exactly that. Next, arc. I'm going to underline in orange. An arc is a piece of the circumference of the circle. So if I go from here to here, that would be an arc. So an arc is just a piece of the circumference. And for 7, 8, and 9, I am going to use these circles at the bottom. So for number 7, I'm going to switch back to blue. A central angle, we have our center, we draw 2 radiuses. That will make a central angle. Have you ever seen that symbol before? This is the Greek letter theta. It is used in mathematics to talk about angles quite a bit. So, you know how side lengths and things that you don't know usually use x as your most common variable? The most common variable for an angle is the Greek letter theta, which is like a 0 with a line through it. Inscribed angle, I'm going to underline in green, is any angle between 2 chords that share the same point. So if 2 chords share the same point, the angle in between those 2 chords is called an inscribed angle. So we're already seeing that this unit's going to have more definitions than other units because we're learning new things already. So, and then in purple here, a tangent. A tangent is a line that touches a circle at only one point. And that point is called the point of tangency. Have you ever heard the English expression where someone goes off on a tangent? Okay? That means they have one tiny bit in common with the idea that was being talked about. And everything else is like, okay, that had nothing to do with what we were doing before. So it's like when I get off topic with a story.
But they don't like remember something as I'm talking to them. Oh, that could, yeah.
Yep, it's just like that. Oh, you want, let's see here, I'll go off on a tangent and I will tell you a bad math joke.
Oh, yeah.
What do you call Mr. Shirk at the beach? A tangent. He's got a good tan going. She's, you know, that wasn't good. All right. And if you would draw a diameter, so here I have a diameter. This from here to here is called a semicircle. Half your circle cut out by your diameter is a semicircle. The big language that you're going to need to know are the central angle and inscribed angle. They're not, I think the central angle, the definition's easy to remember, but the inscribed angle, you have to be able to see that you have 2 chords that share one point, and that makes an inscribed angle. Okay, so here you've got a diagram. Can you use the definitions and fill in all of those spaces? I'll give you guys a head start.
Is it line is above the
Yeah, so if you want to do, when you write a chord, for example, E to C is a chord, and you would write it as EC with a line over top. That makes it a line segment. How did you do? Did you get EC and DC? and CF. And there's more. So when we draw a line segment, we say the letters that are the endpoints and draw a line over top. The diameter is EA. You could have also listed EA as one of the chords. For inscribed angles, so we go angle symbol DCE, angle symbol DCF, angle symbol ECF, and angle symbol CEA. There are the four. The point of tangency, you just write the letter I. Yeah. Now, for radii, AO, FO, EO, and CO, AO, EO, go. Identify the tangent line.
That's what you're gonna name the video.
GF.
JR, I hope you name the video
AO. 5 central angles, angle EOF, angle FOA. You know, I do this sometimes. I start saying words, and then I realize that one of them coming up is like a swear, and I'm like, uh-oh. Not in this case. I don't think we have any swears coming up, do we? Oh, yeah, there is. Look at that. I was just joking. But central angle, the French seal. Yes. So if you wanted to be more appropriate, you could go COF, right? But I didn't want to go there. And which one? I haven't done angle COA. Notice O is in the middle of all of them. Because O is the center. And so this is the preamble. And now there are some beautiful mathematical things that happen within circles. Okay. Now, most of you probably don't have a protractor. So you're going to just have to trust me. I'll pull it out. I'm going to go to that first one, and I'm going to measure the inscribed angle, and I'm going to tell you that it is, turn my thing the right way up, it happens to be 65 degrees. Cool. This one right here, that inscribed angle is 65 degrees. Then I go to my lovely protractor, and I measure the central angle, and it's 130. 130. So I'm going to look at my next one. I'm going to measure my inscribed angle here is 55. And I'll put my protractor on this one. And I got 110. Okay. And I am going to do some measuring here.
What's that first one? 30, 55?
And I measured this one, and it happened to be 55. I measured this one. Here, this one is 45. This one is 30. And this one is 85. And something special happens. Question. You may. Okay, first of all, you should see what special thing happens, because it's the key thing, first key thing in this unit. Okay? There is something that happens in this unit that if you do this, and I tell you this is 50, you should be able to tell me what the central angle is. If that's 50, there's a pattern that happens in the ones above that tells you what this central angle is going to be.
Where are you looking? What? Oh, you just made that one?
I just made one up. And nope. There's a pattern in these ones. If you look at central angles and inscribed angles, and if you see it, you learn the first major rule of circles.
What's that? Is that 50?
This is 50 here.
100.
It's 100. And this is our first major rule. An inscribed angle is half the measure of the central angle if they end at the same points. A central angle is double the inscribed angle if they end at the same points. Okay? So now I can give you a question like this. Shoom, shoom, shoom. Okay? I want you to tell me what this angle is.
What does that say, though? I can't see it.
This says 30. This says 40. What's this angle right there? And you can't get it right away. So if you're trying to just get the answer right away, you will not be able to get it. Instead, in circle questions, you have to say, what could I figure out? Do you see that you have an inscribed angle here with 30 degrees? It has these as its endpoints. Do you see that you have a central angle with those two endpoints? So what's the central angle going to be? 60. So that's the first thing you could label, is that angle is 60. Because central angles are double inscribed angles if they share the same points. So they share the same points. And now you can figure out the angle I wanted you to find to begin with. Yes, this makes a triangle. Triangles, angles always add up to 180, so now you could figure out that is 80 degrees. You could also figure out this is 80 degrees, and this is 100, and this is 100. And once you've got that, you could also figure out that 80 and 30 makes 110, so this is 70 degrees. And so with one piece of information, we can find all of those angles. And that's what some of your questions will be. Here's a drawing. Label all of the angles that happen. Yes? Yes, because these ones are across two lines that intersect, and these ones are in a straight line, so they have to add up to 180.
This is on our next test.
This is on our next test.
This is our next unit.
Now, again, where did I put my little protractor down? Here it is. Check this out. I'm going to measure this inscribed angle. I've got my protractor out. This one is 50 degrees. I'll measure the other one. It is 50 degrees. They both happen to be 50. I'll measure the next one. The next one that's highlighted is 45 degrees. And I'll measure the other one. It's 45 degrees. You can go now.
How did I just know that? I just knew.
Two inscribed angles ending at, here's the key, at the same endpoints. So do you see that both of these have these as the endpoints? Are equal. Multiples of 1.
Wait, which one are you trying to figure out? Oh.
And the reason for that is, check this out. The reason that they're equal is because you could have drawn in the central angle. And that inscribed angle shares the same points as there, so that makes this 100. But if I have that as 100, well, then this one has to be half of it because it shares the same endpoints, so it has to be. And so then we get this sub-rule, which is really helpful if you have two inscribed angles that share the same endpoints. It's going to be, okay? So, for example, I could tell you here that this one is 50. And then that ends here and here. That means this one is 50.
Is that supposed to be the center? Or what?
This dot here is the center. No diameters in that one. You just got chords. But once you have these two, you have a triangle, so you could find this one. I just measured it. I measured the 50. So rule number 1, central angles double inscribed angles if they share the point, same point. Rule number 2, inscribed angles that share the same point are. This is our second last unit. Our last unit is just, we might even only take it, see how much time. It's not one that we have to get through all of it. In the last unit, we don't have a test on. Okay? But this will be our last unit with a test and a quiz.
If we just not do the last one, but the last week doing games.
Oh.
And
If,
if you complete them, you get points.
question though, if we don't do the last one, which one do we end with?
This one.
But this would be our last one then. We shouldn't do it.
Yeah, exactly.
But then
Then we shouldn't do this one because we can't have a last one.
we shouldn't have done the one before then. Oh no.
Yeah, we
Oh,
never
shoot.
should have done any of them.
Okay, I'm going to erase, put zeros in for everything. We didn't do anything. You guys are good to go? Enjoy grade 9 next year.
See you next year.
Yeah, that's a problem for you, Jay.
Okay. So it says here, and again, I have my protractor, so I'll do this for you. It says measure BAC. So I take my protractor out. I measure BAC, and I get 90 degrees. Okay, and I go to the next one, and I'll measure angle back, and I get 90 degrees. How could I know this without measuring it? Well, they're the same shape, but you're just, how do I know it's not 90.3 degrees? It is exactly 90 degrees. There is something on here that tells you. There is a central angle that you know. It's a weird central angle, but this angle here is 180 degrees because it's a straight line. It's technically a central angle, but it's technically, normally we don't go, oh, look at that angle. Like, that's a straight line. I don't see any angle there. You don't normally think of 180 degrees as an angle, but it is. It would also be 180 degrees on the other side. Yes, and on this one too, you would have this angle as 180 degrees. And if you have a central angle that's 180 degrees, do you see that BAC is an inscribed angle with the same endpoints? What's the rule for inscribed angles? Same endpoints as a, right? The center is double, or the inscribed angle is half, and half of 180 is 90 degrees. Now, sometimes, because people don't see the straight line as an angle, they often miss this one. So we make a sort of like an additional rule, but it's really the same rule as before. Okay? Inscribed angles in a semicircle, right, that use a diameter are (90 degrees). They're right angles, which is really cool. Did you know that? Anywhere you pick any point on a semicircle, you draw another perfect 90 degrees. Cha-ching. Draw one here. Oh, look at this little one. Cha-ching. That makes it 90 degrees. Every single spot you draw, which is kind of cool, because those would all be inscribed angles off of that same central angle, cha-ching, making 180 degrees. Oh, I need some new batteries because I have a sound machine. But their batteries are dead. But I have some videos some years when this was working because it has the fart one. So it, like when Nora said, "Can I go to the washroom?" I'd hit the fart button. It'd go, and then I would say, "Yes, you could go to the washroom, Nora." And then that'd be on. That's so. It's on the video. Makes it good. Got to get that sound machine fixed up. Didn't we do that earlier? Didn't you guys like I had the cheer thing? Didn't we do that? That was good. All right. Okay. These diagrams are not drawn to scale, so you cannot use a ruler to solve for them. AOB is 80 degrees. So we can write an 80 right there. Okay? Where usually these questions tell you that you have a center. So we're going to say in this one, this is a circle with center at O. So 80 degrees becomes a central angle. Can you figure out ACB? They share the same ones, right? So this will be 40. Do you see that this one also shares the same ones? It's also 40. You could say it's also 40 either by the half rule, or the second one you could say is 40 because inscribed angles that share the same endpoints are equal. So that one's 40, and that one's 40. So, how would we describe it? What rule did we use? We have to describe the rule. Inscribed angles are half-central angles that share the same endpoints. Are we done? Is there no example 2? Oh, but class is going to go. Okay. We will end there. No, you keep the quizzes to study from.